Nowadays, it's commonplace for CPU and GPU vendors to send reference system designs to important software developers well ahead of commercial release of a new product. Companies like Microsoft and Red Hat and EA routinely get new CPUs and GPUs months or even years before the rest of us have access to them. Now, the first time I heard of this practice was in the mid-90s when Intel began sampling Pentium MMX CPUs to software developers, but I'm sure that the practice predated that. I don't think it was common in the mid-70s. At that time, producers of big CPUs like Digital and IBM generally made a new CPU with some specific system in mind. And they were offering top-to-bottom solutions. So the idea of providing early access to external software developers to make software for their new system wasn't even on their radar. And they certainly weren't sending out CPUs so that other hardware developers could make computer systems based on their CPUs. That was right out. When MOS Technology developed their first CPU, the 6501, they had a clever idea. They made it pin-compatible with Motorola's existing 6800 CPU. So any system that had a 6800 processor in it, you could pull out the old processor, pop in the new 6501, and you could immediately start developing software for it. This would give people wanting to create new 6501 based designs, especially the very first batch of those new designs, a huge leg up because it meant they could start developing their hardware and their system software at the same time. Huge savings in the time to develop a complete new system. Now, Motorola didn't take too kindly to this, and what I think is the obvious lawsuit followed pretty quickly. 6501 is dead. Long live the 6502. Okay, so this is a very abbreviated version of the story, but it's enough to set the stage for the actual point of this episode. So, MOS was in a bit of a pickle. They didn't have an easy way for people to start developing software for their new CPU. They didn't have a multitude of reference designs for people wanting to make new computer systems based on their new CPU. So they made one. And thus the Keyboard Input Monitor, or KIM-1, was born. So straight out of the gate, you can tell that this was a device designed for engineers and not for the general public. Like, that is spectacular marketing right there. Way to upsell your product. This is the original box that this device came in. I'm sure of this for two reasons. The main one being that I have been able to compare notes with another local collector who also has a KIM-1. His box is almost identical, right down to the handwritten serial number on the side of the box. So opening it up, his KIM-1 also came with the exact same anti-static bag. Now, before anyone gives me any grief about anti-static protection, I am using an anti-static strap. I do use protection. I just generally prefer to use the anti-static strap on my ankle because otherwise I find that the cable that tethers you to ground gets tangled up in things and just is in the way and is a nuisance. I'm not usually flopping my feet around while I'm at an anti-static station, so it's not a problem there. I just have to remember to unhook the cable before I get up to walk away. Definitely not speaking from experience there. So inside, you can actually take a look at it. And here it is in all of its glory. You can see, hopefully, the The serial number of the device matches the one on the outside of the box. This particular unit is a Rev F and has the Commodore logo on the PCB. So this is definitely manufactured after Commodore purchased MOS. The other collector in my area has a Rev D board. His board is the green colored PCB instead of this bluish color. And instead of having a Commodore logo here, it's all just filled, this whole sort of oval, whatever you want to call this shape, is just filled in with solder mask. But there's not a lot to this. There's two sort of special chips for this board. The 6530, which is the R Riot. This is pretty similar to the Riot chip in Atari 2600 consoles in that these chips contain 1 kilobyte of RAM and 64 kilobytes, I believe, of static RAM, in addition to the static RAM that's on the board. So the ROM is a mask ROM in it, so if these chips die, you can't replace them with just any other 6530. Various 6530 devices were used in a variety of other machines, including some pinball machines. I think a couple arcade machines used them, and maybe some early Commodore disk drives, but each one had a specific mask ROM, so they're not just drop-in replaceable. It might be possible to cobble together a board that has a 6532 and some sort of external mask ROM or EEPROM to replace it. But that, I don't know. It might be possible, but I wouldn't hang my hopes on it. So in addition to that, there's, of course, the 6502, the RAM that I previously mentioned, some glue logic primarily for the keypad, and the 6-7 segment LED displays, and that's it. Sometimes people will talk about programming in machine language when what they really mean is programming in assembly language, where you're writing in some nice text format and you have a piece of software that's going to convert that text into a bunch of binary values. But this is programming in machine code. You would actually have to punch in manually what address and what value to put at that address, and then input another command to begin execution of the program. It'd be kind of like on a Commodore 64 writing an entire program by just manually typing in poke commands in BASIC is how you enter. Just like start somewhere in RAM and just poke to enter your program that you've manually figured out what all the bytes should be for the actual machine code, and then, cross your fingers and hope it works. If you made a mistake of, F5 instead of F6, well, lots of luck finding it. And that's kind of what's going on here. It has two expansion ports. The E and the A port, and I don't remember what those stand for, but it will be covered later when I go over the schematic. And through one of these ports is also where the power connects. Now, I'm very sorry to disappoint, but I am not powering this thing on in this video. I am way too scared. I feel like if you let the magic smoke out of a super rare computing device like this, it's kind of on the same level as breaking a magic mirror, and I do not need another 7 years of bad luck. I've had plenty already. And the power supply, I do fortunately have a power supply for this. The other collector in my area has sort of a power supply, but it's he's eventually going to post a video, so I'll let him cover it. The power supply that I have is this, and just the way that everything is connected to the edge connector here, and just everything about this power supply says, I am sketchy. Use me at your own peril. So I'm way too chicken to try to hook this up to this device and give it a go. It is nice to have this and the schematics to be able to figure out how a power supply should connect. So there is some possibility that someday I will put together a nice, proper power supply for this and try to give it a go. But I'm still kind of scared. Now, I've told this to some other collectors in my area, and they've asked me what my actual plan is for it, and I'm going to build some kind of a shadow box for it to put it in, maybe with some of the documentation sort of as a backdrop, and be able to display it down here in my basement, so that at least it's not sitting somewhere in this utterly nondescript cardboard box. My local friends have teased me a bit, like, well, if all you're going to do is hang it on your wall, what difference does it make if it has the magic smoke in it or not? You should turn it on. You should turn it on. So someday they might wear me down. I might do it. One of the things about this device was MOS intended it for people who were going to make their own 6502 based systems. They intended it for the WOSes of the world, if you will. But instead what happened is regular people, I mean as regular as hardcore computer geeks ever can be considered, discovered this and fell in love with it. And there was a huge user group with a regular newsletter that had articles about hardware devices people had made to add onto it, and software that people had written, and all kinds of crazy things. Down to games that played on the base system. One of the games that I had heard about that, if I do ever turn this on and get it working, I will definitely punch in all the keys to enter, is Lunar Lander. The first game I ever played on any Commodore machine was Jupiter Lander. I don't remember if it was on a VIC-20 or Commodore 64, but that was the first time I had played that kind of game, and I thought it was so cool. But there was actually a game called Lunar Lander on the KIM, and my understanding is the way that game worked is you used the 7-segment displays to display your velocity, your altitude, and your remaining fuel, and then you used the keypad to set the burn rate for your fuel. So you had to, just based on the display, the numbers on the display here, had to manage the rate that you were descending versus how far you still had to go versus how much fuel you had. I mean, just like any other version of Lunar Lander that you've played on any system, but without the pretty graphics. And in a way, that's kind of awesome, because if you think back about actually landing on the moon, that's about all they had, right? They didn't have fancy scopes and displays and blah, blah, blah. Like, you had just raw data readouts, and, by the way, don't crash. Anyway, so this board is in really beautiful condition. The top looks great. None of these capacitors show any evidence of having leaked or gone bad. The back looks as good as any board of this vintage. I mean, there's bubbling in the large areas of solder mask, but that's absolutely common. Aside from that, it looks outstanding. The cool thing about this particular set that I received is it came with a huge pile of documentation, including the full schematic of the system as a giant fold-out poster. I'm going to open this and kind of pan over it later. Another friend of mine in the local area who also has a YouTube channel it has access to a large format scanner, and so he's going to take this and scan it. We're going to try to make it available online somewhere, just to share. The remnant of the original warranty card, the actual warranty card itself, was sent in. The great thing about this is the original MOS address is scratched out, and just a rubber stamp of the Commodore address is in its place. So they managed to get the PCB updated, but they didn't get the warranty cards updated. Like, okay. I'll get to this in a second here. A really nice quick reference card of the 6500 series instruction sets. All of the various opcodes and their encoding and how they work. Like, I can imagine someone having this right by their side as they're writing machine language programs for this device. Back in the day when I was coding Amiga demos, I definitely had this within hand's reach at all times, and you can see this book has it's seen some use. It was a great reference, so I can definitely imagine someone having this right at their fingertips at all times as a reference. The font is a bit tiny, as you can see, so I guess assembly programming in those days was a young man's game, because certainly my eyes have trouble with this now. The scan of the a photocopy of the original warranty information. A great advertisement, and there'll be some more about this a little bit later, for a housing for the KIM-1. Now, I've talked to a couple of people, and I believe that the size of this housing, based on the size of the board, this might just be within the reach of 3D printing on a fairly large home 3D printer. So if we could get the exact measurements of this old housing, I think it'd be pretty cool to make a few of those cases. That would be awesome. And it came in multiple possible colors. Now, being able to match the blue with the blue of the PCB, that would be pretty awesome. Okay, so there's a specific booklet of just KIM hints, so different sort of troubleshooting hints specific to this piece of hardware. What do the LED digits mean? What to do about other problems? Just a bunch of things specific to this device. So that's pretty cool. A general MOS microcomputers hardware reference manual. This would be more analogous to the Motorola 68000 manual that I was showing a moment ago. One cool thing that was in this was the original owner had cut out a magazine ad for that case. They were originally $23.50, and I am sure that if one of these SKE 1-1 housings ever came up on eBay, even just the empty housing, I mean, the shipping would be $23.50. I can't even imagine how much one of those housings in good condition would sell for. So we have a letter addressed to Dear KIM-1 owner from the Enclosures Group, dated January 18th, 1978. About the enclosures. So I think the other ad was maybe a copy, and that this was the original that came with the letter from the Enclosures Group about their nice enclosure. So that's a cool sort of historical artifact. and then the actual MCS 6500 hardware manual. And there is, I've flipped through this a little bit before. There is just a wealth of information in here just about the 6500 family in general, as there are a bunch of variations of it. We tend to sort of lump them all together as the 6502, but as we'll see a little bit later, there's a ton of different variations that had special quirks to them. Let's see if I can find that. So there's a bit in here about the 6501. May ye rest in peace. There is a brief mention here, and then some more later on, about the 28-pin versions of the 6503, the 6504, and the 6505. Now, these reduced versions, basically they had cut out some of the pins, predominantly address pins. So you had reduced address space, but then it was a smaller package. Instead of a 40-pin DIP package, it was a 28-pin DIP. And in a lot of designs, that smaller package would save board space and would just make the final product less expensive to produce. The Atari 2600 had a 6507, I believe, which isn't covered in this. That was a similar kind of idea. A bunch of the address lines were removed, and that's part of the reason why Atari 2600 cartridges had without bank switching, had a limit of 4 kilobytes, because they had just removed a ton of the address lines. So you physically could not address more than, I want to say the way that the system was designed, it could only address like 6K total, or maybe 8K. I don't remember exactly. But a bunch of the address lines and some of the interrupt lines, I believe, were removed to shrink the package size. But just a ton of information for anyone wanting to make a system based on one of these processors, down to, memory timing diagrams, and just talking about how to design a keyboard for it, and all sorts of different, handling interrupts, working with various peripherals that MOS had created. Just a huge wealth of information. So here's the pinout of the 6502, talking about how to generate clocks for it. Don't know if there's pinout diagrams of any of the... Oh yeah, here you go. So here's some pinout diagrams of some of the reduced versions, the 6503, 04, and 05. So you can see which ones had different address lines removed versus different interrupt lines and whatnot. And just a huge pile of very cool information. And you can, every now and then in this book, I see, where did that go? Little tick marks where the previous owner had read things and made notes, and I'm very curious what his or her intention was with this device. Like, were they trying to design their own system? Okay. So there's a specific KIM-1 user manual, which this had in it. So there's some notes in here about how to create an audio tape interface and how to use these. Okay, so that's what the two connectors are. There's the application connector and the expansion connector. And so this is the expansion connector, and this is the application connector. And the application connector is where the system gets power, and I believe it can provide basically pass-through power for, I think, just 5 volts on the expansion connector. The application connector takes 5 and 12, I believe. Anyway, so then in here there was also some handwritten notes by the previous owner. it's always interesting finding things like this, or the time delay test program. So here's how you did it without an assembler. Like, you wrote out the assembly opcodes, and then by hand you figured out what the hexadecimal values were and what addresses they would go at. So to actually enter this program in the KIM-1, it'd be some combination of entering the address, entering the byte value, address, byte value, right on down the line to enter the whole program. And you can see some places where he had made a mistake. Originally had FE, but oops, it was supposed to be FD. Originally had FA, but it was supposed to be F6. So, with an assembler, you would write these nice text things, and if you wrote the wrong text thing, usually the assembler would say, I don't know what that is. But if you typed the right thing, it would do the right translation to the bytes for you. You didn't have to worry about, oops, I looked it up in the manual wrong, or oops, I punched the wrong key on the keyboard. So it must have just been an absolutely miserable process. Bunch of really great handwritten notes. Getting started, showing the layout of everything. Everything is. Some bits of the schematic sort of broken out into individual pieces. And then some sort of programs back here. I'm not sure. Oh, wait. Oh, no, I bet I know what this is. These dump mem to tape. Oh, no, maybe these. So it's possible, because this is marked 6530-03, which is one of the 6530s on the board. So these would be the assembly. Well, what's actually called a map file. So it has the assembly and the assembled byte values and the offsets, or actually these look like line numbers, for the program of what's in those ROMs. KIM-1 program listings. Oh, that's interesting. No modern computer system will ship with this. You don't, go out and buy a motherboard and it comes with the source code to the BIOS. Those days are long, long gone. So yeah, that's pretty awesome. I'm assuming that all of this is available somewhere on the internet, but if it's not, I am going to definitely try to find a way to get these scanned without damaging these books. These kinds of bindings are not survivors. And then a very large programming manual, just, how to deal with the different peripherals, how to program. Let's go to the actual table of contents here. What the different opcodes are, how the things work. Yeah. Tons and tons and tons of cool information. Quick reference sheets. Oh yeah, the detailed opcode references. So yeah, this book and then the other hardware manual sort of combine, I guess, to be that, like that 68,000 data book. But exactly how the different encodings work, and what how many bytes they are, the opcode number, exactly how to implement the opcode, what flags are affected, all the useful stuff. Summary of addressing modes. Yeah, a ton of cool information. All right. I'm not usually a fan of the handheld shaky cam, but in this case, it seemed the best way to be able to capture this very, very large image of the schematic. Get a good close-up view of the application connector, so you can see that is where the voltages come in, and a good view of the expansion connector also. One thing I really like about this image of the schematic is different parts of the circuit are in these different colored blocks, so you can very quickly tell what things are kind of grouped together and what's what. That was a very nice touch. Since I don't think I'll upload scans of these anywhere, I thought I would just include close-up views of the magazine ad for the custom enclosure and of that handwritten assembly program. So that concludes this introductory video to the KIM-1. My hope is that sometime, possibly in the not too distant future, there will be some kind of a follow-up video to this. What I would really like to do is get the other KIM-1 in my area that I know of, and there may actually be a third, I don't know for sure yet, but get a bunch of them together that are known different revisions. Mine's a Rev F. The other one that I know of for sure is a Rev D. I did a very little bit of side-by-side comparison of them, and there are definitely some differences between the two revisions. So I think it would be fun to look at them, more closely side by side and see sort of how the device evolved. That's usually entertaining, especially if we can get access to a third. I think that would be great. I may eventually get brave and build a power supply and try to turn it on. I wouldn't hold out too much hope for that. I'm a giant coward. Or eventually once I do get a shadow box built for it and get some sort of a nice display built for it, I should have a video showing that. I don't feel too bad about being cowardly about turning this device on. Right around the time I got this, the 8-Bit Guy posted a video where he very briefly discussed a KIM-1 that he had gotten, and he also is too chicken to turn it on. So I don't feel bad after a bunch of the stuff that he's done. Man, I don't feel at all cowardly. And funnily enough, he also had the same idea to just build some kind of a shadow box to be able to display this in. I believe he was intending to donate it to a museum in the local area, at least for them to display. I had a similar kind of idea. There used to be a computer history museum up in the Seattle area, but that has recently closed down for good, and I don't know of another museum of that nature in my area. So if I'm gonna have my device on display somewhere, I'd really like to be able to at least go visit it sometime. So it's difficult to say what the future will hold. But that wraps this up. If you like this video, please click like and subscribe and blah blah blah, all that YouTube stuff. I think you know the drill by now. And hopefully I'll see you again soon.